Hello, I'm Gary Fisk, Professor of Psychology at Georgia Southwestern State University. In this video, what we're going to do is independent samples t-test. We're going to use PSPP software to use this analysis. The data file that I have open here is from my website, garyfisk.com, and look at PSPP for beginners. You'll see this very simple example. The scenario is that we're comparing two groups of students. Imagine that they've had different instructional techniques. It's a very common educational strategy to evaluate new ideas. We've got two different groups. One's getting the standard instructional treatment, and the other's getting some kind of new instructional treatment. We've got standardized scores now at the end of the semester. We're going to compare those standardized scores from the groups to see if one group is showing better performance than the other group. All right, so here's my data file. I've got two columns for this. This first column here, it says independent samples, or IND sample for short. This has got the data in it. This is our dependent variable, if you want to call it that. So here's our scores. And then for the independent samples t-test, we need a second variable. This is IND sample groups. Notice the groups are coded, there's zeros or ones, and that shows what the group membership is. Now that may seem a little odd to you, but let's dive a little deeper into this. Let's see what those codes stand for. If I switch over to the variable view, whoops, let me show that here. In the bottom right corner, I've got the bottom left corner, I've got the data view and the variable view. I'm going to switch over to the variable view. You can see here I've got a value label for the independent samples here. And if I open that, you can see I've coded it this way. The zeros represent people in the control group, and the ones represent people in the experimental group. So it's important to set it up this way. That will help us keep track of which group is which. It's also easy to enter this data into the file as zeros and ones, rather than spelling out control and experimental. Okay, so let's do an independent samples t-test now. We've got our data set up and ready to go. What we'd need to do is go to the Analyze menu, compare means, and then go into this subgroup here. There's an independent samples t-test option in that subgroup. So let's select that, okay? And so here's what it looks like when we bring it open. We've got all of our variables listed over here on the left. We've got to choose which variable we need to analyze. For this experiment, I'm doing this one, or this analysis, I'm doing this one. It's the math experiment. I'm going to select it and use the button to move it over here to the test variable list. We could do more than one, I suppose, but we only have one set up for this one. The next thing we're going to need is PSPP doesn't know how the groups are formed. So we've got to have something that informs PSPP about how the groups are, what's group membership. So if we select the math groups variable here and then use the button again, it moves it over here. It shows it which variable has our grouping information in it. All right. Now we're not done yet. What we have to do now is click on the define groups here, and we have to tell PSPP a little more information about how our groups are formed. We're going to use the top option here. We've got zeros and ones. So group 1 is 0 and group 2 is 1. That's what we'll use for ours. There's some other ways to do this here, but that's how our data are set up. All right, so 0 and 1 for control and experimental group. So I'll click continue to close this. There's some other options available here for confidence intervals and stuff. We'll just skip those for now. Okay, so I've got everything I need configured in my dialog box here. Let's click on the OK button and see what we get. Where are we here? Okay, so here's our output. Right, that's what the output looks like. The top is a table that has some descriptive statistics in it. It breaks it down for each group, tells us how many people, N, are in each group, the mean, the standard deviation, and the standard error, the mean for those groups. The second table here shows us our statistical test outcomes. And there's actually two different things that it shows us here. The first over here this is called Levene's test for equality of variances. This is not the t-test. I see sometimes students confuse this. They think this is the t-test result. This is not actually the t-test result. There's actually two different t-tests that it performs, one with equal variances and one with unequal variances. Another name for these is the equal variances one is sometimes called the student's t-test. That's the classical name for it. The unequal variances version, that's sometimes called the Welch's test. Let's stick with the equal variances one for our purposes today. We'll come back to that in a moment. So here's the column. The T column has our t-score. We've got our degrees of freedom here, and then we have sig two-tailed, that's our p-value. And notice it's 0.000. Now really it can't be truly zero because our probabilities never go quite to zero. That's just the sensitivity that PSPP has. So if we report this in a report, we're going to use 0.001 as our p-value. Okay, so that's the equal variances version. Let's talk a little bit more about why would you want equal or unequal ones. There's an assumption in the t-test that equal variances are used. If that assumption is violated, we have to use the second version here, the one for unequal variances. And that's the Welch's test here. So I would say use the top one for most cases. If this Levene's test is 0.05 or less, then use this second one here for unequal variances. Remember again that here's the t-score, the degrees of freedom, and sig two-tailed would be our probability values. Okay, and then if we want to save these, we go to File and Export. We can save it as a PDF document for easy sharing and storage purposes. Okay, well, thank you for watching. That's the end of our demonstration of how to do a independent samples t-test. Bye-bye.